So now again, hello everybody, now without the echo in the background. So hello again everybody. Welcome to our today's webinar with the title Code Meets Law. For the first time of our webinar, which we're doing for I don't know, 2 or 3 years now, we do it in English, so welcome also to our international guests. We decided in this case to switch to English compared to German in the previous webinars, because the topic is, well, very special, highly discussed currently in the IP sector. And so we are also happy to give you some insights in our work in the respect of computer implemented invention as a very rough keyword. Prior to start, I just want to inform you that we are recording this webinar. At the end, you will receive via email the webinar and the slides. So if you miss something, you can hear it again, get all the information again, and also go through the slides again. And with this, I want to introduce to you Dr. Hendrik Standke. Thank you that you have the time and give this presentation. Mark studied physics in Bonn, did his PhD also in physics, and also during his PhD time he started getting into contact with the IP, but also getting into contact with artificial intelligence, with computer and so on. And since 1.5 years, he's now focusing on IP because he's doing his traineeship in our firm. So he will be a patent attorney in 1.5 years, approximately 2 years, whatever. Fingers are crossed for the examination. But also due to his startup, which he is founder of, he's very intensively working with this topic of software invention, software. Can it be patented? What is the criteria? And what is this computer implemented invention? When do we have an invention? What is possible? What is not possible? Of course, with the focus of Europe, because we are located in Germany and in Europe. And so I'm very happy, looking forward for the presentation. And for the audience, at the end, we will have enough time to answer questions. And so, yes, the floor is yours. Thank you very much.
Thank you, Eva. Yeah, thank you, everyone. Thank you for being here this afternoon. Great to have so many of you in the call here today. As Eva correctly said, my name is Mark. I'm working here since 1.5 years as an IP trainee, and I'm actually a developer myself. So this is why I'm very pleased to give this presentation today, and with the title Code Meets Law. And the aim is to give you guys some insights into the criteria that the European Patent Office attributes to patents concerning software. And prior to this talk, I was actually thinking about what are the main 3 questions that you guys should have answered after this presentation today. And I would like you to take at least 3 things away from this presentation. The first one is, what is actually a computer implemented invention? So when the European Patent Office writes something about computer implemented invention, what is that? The second thing is the topic or the explanation, hopefully, why software is so hard to patent in Europe. Now, we hear a lot from other clients, especially from other jurisdictions, that software is really easy to patent, and that's very different from how it is in Europe. And I will be trying to give you an explanation where this may arise from. And last but not least, I will give you guys a little insight on how what the European Patent Office actually does in order to determine if your computer implemented invention is patentable. And I've brought 2 examples that we can go through, and then based on that, maybe also discuss after the presentation the nitty-gritty details on how this works. Okay, let's start with the first question, which is, where I would like to answer what is actually a computer-implemented invention. So according to the EPO guidelines, it says a computer-implemented invention covers claims which involve computers, computer networks, or other programmable apparatuses, whereby at least one feature is realized by a program. What does it mean? So especially the programmable apparatus part is actually pretty broad. So it doesn't only include computers, but it also includes microprocessors, microcontrollers, FPGAs, anything that you can think of that takes a set of instructions and executes it on an electrical machine. And important is also, it's not sufficient to just have any kind of computer or any kind of machine. It needs to be a machine that actually runs a program or a set of instructions. How do you actually recognize a computer-implemented invention when you see it in claims? There's at least 3 ways how you can patent a computer-implemented invention. The first one is you can choose to patent the product itself, so the thing that the code actually does. And an example claim for that would be a computer-implemented method comprising the steps A, B, C, D, and so on and so forth. The other thing that you can patent is not only the procedure, but you can also patent the device that is running this procedure. And an exemplary patent claim for that would be, for example, a data processing apparatus comprising the means for carrying out the method, the steps of A, B, C, D, and so on and so forth. And then last but not least, you can also patent the storage medium, which would be equivalent to a CD or a thumb drive, something that you can take physically into your hands. And an example claim for that would be a computer-readable storage medium comprising instructions which, when executed by a computer, cause the computer to carry out the steps of A, B, C, D, E, and so on and so forth. So these are the claims that you can easily, or these are claim examples with which you can easily recognize whether a patent or an application is a computer-implemented invention. So now that we have all common ground what a computer-implemented invention is, I would like to come to the point and explain why software is so hard to patent in Europe. And for this, we can actually really easily look into the European Patent Convention, more specifically Article 52(1) of the European Patent Convention, which states that European patents shall be granted for any inventions in all fields of technology. All fields of technology, that's important, keep that in mind for later. And then the 3 conditions that are standard and are probably very common in most of the patent jurisdictions, provided that they are new, include an inventive step, and are industrially applicable. The main point here is that European patents shall be granted in all fields of technology, which would naively also include computer-implemented inventions. But there's a catch, because when we read just a little further in Article 52(2), there's a list of inventions that are explicitly non-patentable. And this list includes discoveries, scientific theories, and mathematical methods, as well as aesthetic creations, schemes, rules, and methods for performing mental acts, playing games, or doing business, and explicitly programs for computers. And this is actually a little bit contradictory, because usually we would assume that a software or program is part of all fields of technology, but it's explicitly exempt here. And when I read this the first time, I was wondering how can that be? Like, how come there was no reform of the EPC that fixed this in time? But actually there was, so we'll come to the point and explain how that came. And actually there was a proposal to rework Article 52 during the EPC 2000 negotiations. And as some of you may remember or may know, that there was a big reform around the year 2000 of the European Patent Convention. And there was a proposal to include this little phrase that we now have in Article 52.1, which states in all fields of technology, and remove also the phrase and programs for computers. So they were actually thinking about this already 24 years ago. But as you can see, and that we talk about this today, this did not come through. And the reason for the rejection was actually that at the time, the European Patent Commission had initiated a proposal to harmonize the European national patent laws concerning the patentability of software patents around 2002. And the EPC 2000 was signed in winter of 2001. So they didn't want to take a decision for the European Commission, which may have been overruled a couple of months later. But unfortunately, the European Parliament rejected the proposed EU regulation, and therefore we're now working with what you've seen in the previous slides. So we've established this little contradiction, and as contradictions go, you of course need to have a way to resolve them. And the EPO actually has a very formalistic approach of working through their office actions, and they have also come up with a very systematic way of determining whether a computer-implemented invention is patentable or not. And this is actually done by a modified problem-solution approach. So for those of you who don't know the problem-solution approach, this is basically an algorithm that the examiner uses to determine whether your invention is inventive or not. And in 2019, the Board of Appeal came up with a modified version of this problem-solution approach, the so-called COMVIC approach. The name is based on one of the parties that were involved in the decision for where this approach was applied for the first time. This is where the name comes from. And this modified problem-solution approach is then used to determine if something is patentable as a computer-implemented invention or not. So let's imagine that an examiner gets a new application on its desk, and the first thing that he wonders is, does the claim that I see here actually contain features that may be part of a computer-implemented invention? And if the answer is no, then he will just continue with a regular problem-solution approach. But if the answer is yes, or he's unsure and it may be just part of a computer-implemented invention, he will apply the COMVIC approach and start looking for prior art. But the selection of the closest prior art is a little bit different in the COMVIC approach compared to the problem-solution approach, because even before the examiner starts searching for prior art, he already examines what features of this application are technical or contribute to the technical character of the invention and which don't. So he really just searches for prior art that includes these technical features. So he already has crossed out a couple of the features in our invention. In the second step, he then takes the features, the technical features that are left over, compares that to the prior art that he found, and if he finds no differences between the prior art and the features that are left over, then they're basically identical. Your application is not novel, and you will get a rejection according to Article 54 EPC. Then, in the second case, there may be differences. There may be differences between the prior art that the examiner found and your application, and the examiner compares them, finds differences, but he's of the opinion that these differences are non-technical or don't contribute to the technical effect, and therefore he will label your invention as non-inventive and raise an objection according to Article 56. In the best case scenario for us, he sees differences and also thinks that these differences are technical and contribute to the technical character of the invention, and he then continues with the COMVIC approach to the last step, where the examiner wonders, are these technical contributions obvious? So would it, for example, been obvious to use an FPGA instead of a microcontroller? Something like that. And if he thinks that these technical contributions are obvious, then he will again label the invention as non-inventive, raise an objection according to Article 56, or if he concludes that the technical contributions are non-obvious, he will, in the best case, affirm patentability if everything else is okay with your application, and you will be happy owner of a granted patent soon. Here's a quick summary of the differences. So it's of the differences between the problem-solution approach and the convic approach. You can see the 3 steps of the problem-solution approach, which are determine the closest prior art, formulate the objective technical problem, and then checking for the obviousness of the new features in your application. And the convic approach basically does the exact same thing, but at each of these steps, the examiner wonders in his head, are these features that we are talking about actually technical? And this is a much higher hurdle to take for your application if the examiner wonders that in his head. So we've been talking a lot about technical character, and we've only introduced computer-implemented invention, and with this I would like to give a little relation between the two, because we have this contradiction in the EPC where it says that inventions can be granted in all fields of technology, but not software. And the EPO actually interprets it that way. As long as your software includes a technical effect, it may be patentable. And the further technical effect is defined here. A technical character must produce a further technical effect when run on a computer, and a further technical effect is a technical effect going beyond the normal physical interactions between the program and the computer. That's the official definition. When I read that the first time, I was like, okay, that is not very helpful. So I looked at a couple of concrete examples, and I found these 3 decisions. The first one is from 1984, where the Board of Appeal decided that a technical character can be indicated by a method having an overall technical effect, such as controlling some physical process. This is actually also a really good best practice to keep in mind, as long as you can link your computer program to some physical process, such as a manipulator or a robot or some sensor that is taking real-world data, then this is a good argument to argue why the invention is technical, because of this link that you've gotten to physicality and this physical process. Then the second invention basically just states, as long as there is a technical interpretation of your claims, then this is maybe enough reason for it to be technical. And the last one I actually found quite interesting, because it explicitly states that improving the ergonomic operability of some machine, desk, whatever some human may use, that improving this operability is a technical problem, as long as the parameter that is optimized is a technical parameter. Yeah? So for example, if you adjust the height in meters or so, this is a technical parameter, as long as it's measurable by a device. And then actually I found another list in a book here in the library, which I found really helpful, which has even more concrete examples what has been considered technical in the last couple of years by the Board of Appeal. So in the first row you again see this example of the physical process. So as long as you can link it to a physical process, it's an argument for technical character. Then, when you only have a computer, if you can make it more efficient in terms of energy usage, memory, processor usage, input-output interfaces, then this is also an argument for technicality. But with this, it's also very important to keep in mind that you describe very accurately how this is achieved. It's insufficient to say we are now storing our data in a blockchain instead of a database without specifically stating how you store the data in the blockchain and what effect or technical improvement this may have. Then in line 3, when you improve something physical on the computer, like the keyboard, terminal itself, mechanical systems that are in your computers, that's also a reason for a technical character. When you increase some bandwidth between components, either by protocol or also by hardware, that is an argument for technicality. And increasing security and reliability, or the overall IT infrastructure in itself, is also a good argument for technicality in your application. So we now have all the tools to have a look at an example. I have brought 2 examples. The first one you can see here. I will just read the claim and then we will go through that step by step, what will go on in the examiner's head. So let's read the claim. The claim concerns a method of facilitating shopping on a mobile device wherein the user selects 2 or more products to be purchased, and the mobile device transmits the selected product's data and the device location to a server. The server accesses a database of vendors to identify vendors offering at least one of the selected products. The server then determines, on the basis of the device location and the identified vendors, an optimal shopping tour for purchasing the selected products by accessing a cache memory, and which optimal shopping tours determined for previous requests are stored. And the server then transmits the optimal shopping tour to the mobile device for displaying. So in simpler words, this concerns an app where the user can just add 2 items to its basket. These 2 items, the server then looks up where these 2 items are available, and then based on that calculates the optimal shopping route for the user and sends that back to the user device for display. Let's see what the examiner thinks of this claim. So in this example, the examiner thinks that the features contributing to the technical character are at first glance identified as a distributed system comprising a mobile device connected to a server computer which has a cache memory and is connected to a database. I've highlighted for you guys the technical features in this text. So in other words, the examiner only thinks that the inventive or the technical part of this invention is a distributed system with a mobile device, a server, cache memory, and a database, which is basically your arbitrary web app. So he hasn't attributed any of the special features such as the adding of multiple products to your shopping basket or the calculation of the optimal shopping tour. And in our examiner's head, this would then look like this. So I've highlighted the green features are the features that the examiner considers technical. And the crossed out features are the ones that he actually never even considered because he thinks they are non-technical. So the examiner then, based on these features, searches for prior art and actually finds prior art, which is document D1. And document D1 discloses a method for facilitating shopping on a mobile device, wherein the user selects a single product and the server determines from a database the vendor selling the product nearest to the user and transmits this information to the mobile device. So the difference between our application and this prior art is basically just that the user adds multiple products to its basket, and that based on these multiple products, the optimal route is calculated, instead of just looking up in a database where this individual product is, like described in D1. And when we then look into the examiner's head again, you can see the yellow features are the ones that are now disclosed in D1. So he crosses them out as well, as already known from the prior art. And you can see there's only one technical feature remaining in green, which states that an optimal shopping tour is calculated by accessing a cache memory. And as you can all imagine, this is not very specific, because also Google Maps calculates the perfect route for you and also accesses a cache memory throughout the full procedure, probably somewhere. So the examiner goes again, searches for another piece of prior art, and in this example he also finds another piece of prior art, document D2, which discloses a traveling planning system which accesses cache memory for storing results of previous queries. And when we then look at our claim again, I've highlighted the last remaining technical feature as disclosed by document D2, and there's nothing left of our claim despite us having features in there, such as adding 2 products to our basket and calculating the optimal shopping tour. But the examiner just doesn't consider them because he doesn't consider them technical, and it was also not possible to guide the examiner in a way that he would classify them as technical. Yeah, this is the first example. I've also brought a second example, which is a little bit different. And after looking at the 2 examples, I will shortly summarize what went well in the first one and maybe not so well in the second one, or vice versa. But let's jump right into the second example invention. So the second example invention concerns a computer-implemented method for determining areas in which there's an increased risk of condensation for a surface in a building comprising the following steps. The steps include controlling an infrared camera to capture an image of the temperature distribution of the surface, receiving mean values of the air temperature and the relative air humidity measured inside the building over the last 24 hours, then calculating based on said mean air temperature and mean relative air humidity a condensation temperature, which is also called the dew point, at which there is a risk of condensation on the surface, and then comparing the temperatures at each point on the image to set calculated condensation temperature, and based on that identifying the image points having a temperature lower than the calculated condensation temperature, which would indicate areas that have an increased risk of condensation. And then based on that data, the infrared camera image contains colored highlights, which indicates these areas of increased condensation. So what does the examiner think of this in this example? The examiner, so when the examiner reads this, in this example, he concludes that the control of an infrared camera in feature A clearly marks a technical contribution, and he's not quite sure yet whether steps B to F also contribute to the technical character of the claimed subject matter. So in this case, he will follow the convic approach, of course, and but we've actually already taken the first hurdle, because when you read the underlined and bold text, he concludes that the claim is not directed to a mental act, a mathematical method, or presentation of information as such, which would be excluded from patentability under Article 52(2), as we've seen in the very beginning. So we are already in the realm that the examiner has established that it is a computer-implemented invention, and he's just not sure yet if it's technical or includes a technical effect as defined by the EPO. So when we look in the examiner's head, we can highlight feature A because he concluded that this is a technical feature. And about the rest of the features, we cannot yet really make up an opinion. We can only make that opinion up after the examiner has found some prior art. And of course, the examiner also finds prior art. In this case, which is document D1 that discloses a method for monitoring a surface to determine the risk of condensation forming on it. And the risk of condensation is determined based on the differences of the temperature readings obtained via an infrared pyrometer for a single point on the surface. And the condensation temperature is then calculated based on the current ambient air temperature and the current relative air humidity. And then there's just a numerical value displayed for the user for interpretation. So the differences between this prior art and our application are basically that we are using a different sensor. So instead of an infrared pyrometer which only measures points, we use an infrared camera that measures the full surface. We are also using mean and averaged values for calculating the condensation temperature. And we are also working with areas instead of individual points like the invention, and we then highlight these areas on an image. So when we look in the examiner's head again, the green feature is the one that's considered technical. The yellow features are the ones that are disclosed by D1. And I've also already crossed them out because they don't contribute to the invention, to the inventiveness of the application anymore. And I've printed the differences in bold and as underlined. So we have the difference of using infrared camera, as mentioned before, using mean values instead of current values. And we have the difference of coloring something in an image and working with areas instead of points. And then in the next step, you may remember that the examiner again wonders, what of these four features, these differentiating features, are technical? And I've summarized this for you guys here in a table. And in this example, the examiner concludes that using an infrared camera instead of an infrared pyrometer is actually technical, because it's a sensor, it's related to a physical process. Using mean values to calculate the condensation temperature is also technical, because it's a different value related to something physically measurable. And identifying critical points as areas is in this example also considered technical, but using colors for displaying something on an image is not considered technical. And then, remember, we have 3 steps for determining the patentability in the Convic approach. And then the last step, the examiner wondered, is this obvious? Is this change, is this difference actually obvious for the person skilled in the art? And for the first feature, the examiner actually concludes that using an infrared camera instead of an infrared pyrometer is obvious. So, I mean, the infrared camera is just the next version of the infrared pyrometer. It's just a bunch of point measurement things stuck together. So this does not contribute to patentability. And then the next question is the use of mean values to calculate the condensation temperature obvious? There, the examiner concluded, no, this is not obvious. So this feature contributes to patentability. And identifying critical points as areas is also non-obvious according to the examiner, and therefore this feature would also contribute to patentability. So in total, this invention involves an inventive step, and if everything else is okay, it might most likely be granted. So we've now seen 2 examples. The first example was an example where the patent would have most likely been not granted, and the second example was one where the patent would have likely been granted. What are the differences between those 2? The differences are, so in the first one, the problem is that the differentiating features are, from the beginning not considered technical, and the features that might be considered technical, which is the way how the ideal route is calculated, the way that the data is processed and stored in the server to calculate this optimal route. This is not really broadly described. It only states there is an optimal route calculated, and we use a cache to access this or to retrieve this optimal route. And these are just two steps that are super generic, and based on that, it's very unlikely to get a patent. And the second invention, it is there are much more features that can be used in the application process to argue where this technical effect comes from, because it specifically describes what values are used to calculate a new value, what sensor is used, how is it displayed, are we talking about points or areas. So it's really much more likely to get a patent or a computer implemented patent in Europe when you add lots of features in the technical part of your invention. So coming back to the example, it's insufficient to just say, yeah, we're now using blockchain instead of a database. You really have to state how the data is stored in the blockchain itself. Yeah, exactly. Let's summarize what we have learned today. So we have learned in the very beginning about this contradiction in the European Patent Convention, that generally all inventions or inventions in all fields of technology are patentable, but explicitly not programs in computers. The EPO circumvents this issue by using a modified problem solution approach, which is the so-called convict approach to raise objections based on technicality. And this is maybe also a takeaway. The EPO will never explicitly cite an article for technicality. Your technicality, or the reason why your patent is not patentable due to technicality, will always be together with the objection according to Article 54 or Article 56, as you've previously seen in the convict algorithm. And then the best argument for technicality is really ensuring a relation to some physical process, such as having some relation to a robot or a sensor, and then really specifically describing how the data is processed, how it is stored, how it is accessed, what data type it is. These are all arguments that are really helpful in the granting procedure. Yeah. With this, I thank you all for now. Thank you for your attention, and I'll give back the word to Eva.
Thank you very much, Mark, for this very, very interesting talk and giving just a summary over this really complex topic. I know half an hour or 40 minutes was it now is definitely too short to have each and every aspect, but I think it was really a good overview to get in the first touch with this topic. And so now we still have some time for some questions. So you may either raise your hand or just write in the chat your question. So if you hold up your hand virtually, the microphone will be opened. So far no question, but I have a question actually. We're now introducing all the aspects at the EPO. Is there something similar at the German Patent Office, or would you always recommend, in case of computer implemented invention, to prefer the EPO? Is there a so the EPO, it seemed to be very clearly structured, and there seem to be experience. The question is there something similar at the German Patent Office, or is it difficult?
That's a good question. So in my work, I've mostly been working with European patents, so I haven't had much touch points with how the German Patent Office handles German computer implemented inventions. Maybe that's a good topic for another webinar.
Okay, that's fine. But I see we also have in the audience some questions. So the microphones are now open. So Mingzo Choi, if I can read the name correctly, if you unmute yourself, you may ask the question.
Good afternoon. Can you hear me?
Yes. Yes, thank you.
Okay, thank you. Very interesting presentation. It was very informative for me. Okay, I have a question here that you mentioned in your presentation, that presentation of the information is not patentable. Okay, if you look at some computer programs or mobile apps or anything like that later, it is the presentation of the information either one way or the other way. We are taking some data from one places, from the different places, processing it and presenting it to the different form. So I couldn't get this point that what does this mean? Could you please elaborate a little bit more? Thank you very much.
Yeah. Thank you, Mubasa, for your question. So you're indeed correct. In Article 52.2, it also says that the representation of information is not per se patentable, but of course the same the same procedure would apply to that as well that we've seen for computer-implemented invention, because as long as your representation of information is technical, so as long as you can argue that your process gets more efficient in terms of energy storage, whatever, then this would be an argument for patentability. But if you just say we are casting this data type to another data type just for the pleasure of the human eye, this is maybe something to spend more time on, to think about features that may be worth adding to emphasize on the technicality.
There was just another hand raised. Any further question? Please feel free to ask. So I repeat, there was one question now in the chat. Sorry, my microphone isn't working. Why would identifying critical points as areas be considered technical and tied to the problem being addressed, but using colors for displaying are not considered technical?
Yeah,
you may comment on this.
Good question. So we first need to differentiate so the one thing is a definition of a data type. So we're talking about areas, which is a bunch of points. So this is a technical difference in the way how this data would be processed. And the representation of this data is exclusively taken out by Article 52.2, such as, for the same reason that Mubasa just mentioned, that the representation of data itself is insufficient to be based on as a technical effect.
We have a further question of Stefan Burauer. You may also open your microphone.
Thank you. I'm just following on this question. Okay, colorization is not technical, but each color has a different brightness level. So I mean, a dark blue has another brightness level than a light yellow. If I would have made it on a brightness level, so then it would be technical, wouldn't it be?
That's a very good point, because you're technically right, and it's not so much about the feature itself, but what we argue in combination with that feature, how we make it technical. For example, when we can say, we are reducing so when we display this color, then we are reducing the brightness values, for example, to make the storage more efficient. Instead of 8-bit values, we now use 4-bit values to store those, or we use a smaller color range to store those. Then this, of course, would be an argument for technicality. But just saying, we display something with colors for the pleasure of the human eye is insufficient.
Yes, but I mean, it should have been addressed on the brightness level. That was my thinking as I read this thing. Thank you.
Okay.
Any further questions?
One more.
Yes, please.
There are two examples here are those examples out of the guidelines, or are those examples you encountered in your daily business work?
So these examples are from the guidelines. I've also linked the sources and the slides that you will get after the presentation. But I mean, you encounter such examples also in the day-to-day business, and they feature similar problems to what we would usually see in applications.
Thank you.
My pleasure.
I think the question with the display of the color, and if it's simply the color to look nice, or whether it has something to do with the storage size, with brightness, shows that the topic is quite complex. And it also shows that, at least for me, you know, I'm a chemist, for me this is all kind of very, very special, but also in chemistry you're getting more and more in touch with these questions. That you need a certain creativity to think of what could be technical and to argue for technicity. So I think it's, well, if you think maybe from a first aspect, it's just computer, it's just software, I don't get it patented. Just think of what is behind it, or think what could be technical. So it doesn't have to be this huge technical thing, but some small features, everything which is just not only for looking nice, everything you may think of would be sufficient to say it is technical.
It will at least help finding arguments for the patentability, yeah. And this is really the main takeaway here, that when we're looking at computer implemented inventions, that it's important to have the software part defined really systematically, you know, like as many steps as possible, with as many details as possible, and already with a technicality in mind, that you can already save, or that you don't write a claim which states the user puts 2 things in his basket, or at least you don't count those as novel features already, but you really focus on the algorithm itself that states, okay, value A is taken, then value B is taken, what types are these values, how do they change? And then based on this, I mean, not all of this always lands in your claims, but this gives the attorney a really good, bag of arguments for getting your application then granted in the end.
I think the topic of software, computer, and now also with the artificial intelligence, neural networks, all these keywords which are kind of scrambling around everywhere, will keep us busy during the next years. There are some cases pending, trying to find answers for different questions. What is patentable? What is not going on nationally in Germany, in Europe, but also in the international way. Yeah. And I think we are trying to stay on the forefront, and we try to keep you informed. And so especially the topic with neural networks seems to be something to be discussed during the next 1 or 2 years. What is possible, what is not possible, how to include this into the systems of computers and softwares, and I think it will be very, very interesting to see how this is going on, and of course we will keep you all updated. And so if there are no more questions, last chance. No, not last chance, of course, because whenever any question occurs, please feel free to contact us, write an email, write over LinkedIn chat. And so thank you very much for your time. As mentioned in the beginning, we will send you the slides and the recorder of this session, and whenever question occurs, please feel free to ask us. And so we wish everybody a nice evening, a nice day, a nice afternoon, and thank you very much for your time, and of course thank you, Mark, for giving this very, very nice presentation.
Thank you. Thank you. and enjoy your day.
Bye-bye.